the afternoon. We just had lunch. It's been a couple hours. So my question to you guys is, why are we here today, right? So my personal answer is, when I look back 20 years ago, when the internet and search engine revolution started, right? I was looking at my friends working for Google, all these companies. I think, okay, wouldn't it be great if I bought some stocks from them? Wouldn't it have been better if I worked for Google? Now fast forward 10 years later, is the revolution in mobile computing, right? So same thoughts crossed my mind. Wouldn't it be great if I worked at Apple or some of these companies? What if I bought stocks? No, I didn't, right? Some of you might have caught those revolutions and benefited from those. But here I think I can say, including everyone in the room today, we are a part of the mobility revolution, especially in the drones. And 10 years later, we can look back and hopefully all with a smile on our faces, right? Because I think we're all going to benefit from this. And we're helping society change the way we live once more. Okay? So having said that, let's take a look at what exactly is an industrial drone from the Lidar perspective. So this is a Lidar, just a generic image. It's not associated with any brand, just be market neutral. And on the bottom is one of our latest sensors. We call it the puck. The latest version is under 600 grams, and we have our plan in place to make it even lighter later this year. And I think most people, when they hear the word Lidar, it's a little bit scary. We have our tools out there that you're welcome to see. We have our Director of Technical Solutions, Dave Oshnik, and Mike Parson, part of the team. They'll be happy to show you the sensor in action. But what I'd like to talk to you today is more about the solutions, right? What are the problems we're seeing? How are we helping our customers solving the problem for the end users? Because if you look at the cell phone, right, I think we take it for granted today. Nobody thinks about how much processing calculations is going on within the phone. I mean, recalling back to my electrical engineering days, charging the phone is actually a very complicated process, right? Some of you might wonder why when you get to 99%, it takes a longer time to get that last percent. I think because the phone actually needs to slow down the charging process so you don't overfill like your bathtub, right? Because the phone could actually explode. So that being said, I think in the vision is, say in about 2 years or so, Lidar, at least from a drone's perspective, will get commoditized. Not that the technology itself is not critical, it will be, but we don't need to worry about how complicated it is to integrate a Lidar onto a drone. And Velodyne is looking forward to working with the different players in the market to make that happen, right? To make something very complex and simplify it. So let's look at what is inside this solution. Whoops. So, color-coded green are the modules inside the drone today, right? And please don't complain if I don't have the battery as a box in there. And then the orange are software modules, at least the key software components to make the Lidar payload work. And beneath that, we have some of the sensor examples and hardware diagrams like CPU. We have camera, like we all know today, on the DJI drones and 3DR and the like. Of course, we have the Lidar. But to make all these work, you will need the IMU data, right? You need the GPS. Some of you have, I think, done this already. Some of you are looking into it. And many more people are just wondering, how do I leverage this technology? So now we know what's underneath the onion. All right, we'll peel layers off the onion here. So let's look at what are some of the problems we're solving today using Lidar. And I will say all these have happened in the last 12 months or so. Some examples, pipeline inspection for oil and gas. We know customers today they used to be driving a truck across a new pipeline construction site, right? To making sure the dirt has been excavated at the right depth. Everything is done nicely, and now they're looking to use drones to make the Lidar as a measuring device, replacing the truck and the driver, right, to automatically figure out you within specification, because we know the cost of failure in energy is very high in the pipeline app. Next one is rainforest. So we have customers. I think one example is in the Amazon rainforest. They're using Lidar because we have so many lines of resolution. You could penetrate the leaves, not only measure the canopy, what's on top of the rainforest, but also the floor, right? So you can get a nice volume calculation to see how much forest you actually have. And you can actually quantify the greenhouse effect, right? So to speak. Next, public safety. So this is outside of the United States, for this application at least. So we have a customer designing a drone solution using our Lidar as a sensor buoy device, right? So it's using it to understand the environment, the 3D environment, to prevent accidents from the user. And in this case, the operator is a firefighter, right? So they plan to have one drone system with our Lidar for all the main firefighters in the country, right? So that will prevent accidents. Coal mine asset management, similar, I think it's a volumetric measurement as well. Some of you already talked to me about this today. So that's also a rising application. And hazardous gas detection, notice the asterisk. So I'm not saying Lidar could help you figure out the chemical content in the air. In this case, the customer has a unique technology to actually penetrate the glass outside of a building to figure out is there a gas leak inside the house. Our sensor is used, again, for collision avoidance in real time, so that the operator do not crash into a glass or crash into a building or wall, okay? And lastly, but not least, is power line inspection. And so this is quickly happening. I think later this week you'll hear a presentation from a company that's specializing in this field. And we hear a lot of market reports about how today utility companies are spending billions of dollars using manned aircrafts, surveying millions of miles of transmission lines. So we also see a rising demand using Lidar to help you understand their obstructions from trees, the broken wires. I think if you read the news, southern China suffered the coldest summer for a while, last year I believe. So they have a huge amount of ice accumulated on the transmission lines. So Lidar could have been a great tool to actually measure how much ice you have, how long would it take to clear that. Okay? So looking at the applications, these are just a few examples. And I would say in 12 months when we regroup again in this room, this list will multiply, right? So from a solution standpoint, it's very difficult to actually have a standard solution for each one of these applications, knowing there will be more to come. So what we have done is we started talking to customers throughout the ecosystem, so to speak, and we identified a smaller number of drone operation modes. At least that's how we're calling it today. So drone operation modes is almost like a way of segmenting the market to figure out what are the common problems these applications are trying to address, and let's work together to design those a solution to solve those problems. So before I go to the next slide, maybe just a question, take a guess, right? So how many use operation modes you think we have identified, at least from Velodyne's perspective? Anybody want to take a guess? We have a shy group here. So 100, close. Actually, there's about roughly 3. But next year we might actually have 100. Right? So what we have on the bottom, we're calling it passive mode, and in the middle, active mode, and ultimately the third being autonomous. And again, at least I haven't seen a standardization in the terminologies we use, so just bear in mind these are our internal view. Yours might be different, but after talking to some of the players in the market, including enterprise level companies, I think we all converge at these three, at least for now. If you feel there are others, please let me know. We'd be happy to talk to you. So the first one is passive mode. So what we mean by passive mode is the earlier adopters of LiDAR technology on drones have been just flying the drone with LiDAR as a payload. There's really no communication between the drone itself, the flight controls, and all that with the drone. The drone is really just scanning the environment, right, either downward or around, storing the point cloud and saving it for later where you do a post-processing, right? So that's what we call passive. The drone and LiDAR not do anything in real time about the data, but really save for post-processing. And most of our customers look at our website. We have many integrators in this space that's doing surveying and mapping. So those are in the passive mode. So next, active mode. What we mean by active mode is, so now the opposite of passive, right? So now there is some communication, some real-time processing on the drone system using the LiDAR data. For example, if you're inspecting a wind turbine, right? So in real time, you probably want to know where that turbine is, like the dimensions, the sizes, and how do I fly around it without hitting the blades. So we have customers in some of these spaces, and they are actually processing the LiDAR data in real time now. Okay? I think the key difference between autonomous and active mode is, I just want to point out, so for active mode, we don't see how the drone could operate anywhere in the world without having you maybe manually fly it up and down to learn about the environment first. So that's the key differentiator between active mode and autonomous mode. And I saw Colin nodding his head, so I think we're not completely wrong here. So autonomous mode is essentially like autonomous car, and we have some samples that we can show you where the drone could perform real-time sensor deploy and actually make trajectory alterations based on what's in its path. So delivery down the road could be a big application within this operation mode. Okay? And interestingly, what we found was if you look at our earlier version, which is still a standard product today, called the 32, so 32 lasers, and then we have the PUG, the 16, which is much lighter at half the laser count, but still equal in performance. The question becomes, what is the application problem you're trying to solve? And then we'll provide you the right sensor, right? So for mapping applications on the drone system, some of the customers are still using the 32 just because it's a much higher accuracy device, and you're getting the 32 laser, much better resolution. But with sensor void, all you're really doing is not surveying, you're trying to understand the environment. So the 16 makes perfect sense. And later we'll be happy to show you the product itself. So let's touch on, as a last, in closing, let's look at what is the market ecosystem. Velodyne is really the sensor provider, right? We give you a technology, the data, and you can develop the whole solution. But as we talk to different players in the market, we really feel we're positioned in a so-called market neutral space. A lot of people come to us, even though they might be competitors in the same segment, but they all see LiDAR being a common data input, right? So this way, we're actually seeing a lot of the latest developments in the market throughout the ecosystem. And I think the approach we're taking as a company is a positive one. I think the opportunity in this market is emerging fast. Let's not worry about who's competing with whom. Let's worry about, right, how can we put something together that solves a problem for the end users. And we have the, at the top level, we have the regulatory influences, the dynamics, such some of you have already heard today, plus the technology that's quickly changing, that's also affecting the whole ecosystem. So in closing, again, I think Velodyne is looking forward to working with everybody in the room and everyone else who's not in the room to come out with the solutions to drive standardization in this quickly emerging industrial drone market. Thank you very much.